Alright, welcome to part 2. We're starting our review, and the first part is this question A. So if you would jot down this question, and on your, we're on our bingo sheet, creating a study sheet. So if you would jot down this question, we have 22 meters per second, 35 degrees is the angle. The goal is 2.4 meters high, and it is 32 meters away. We need to know if it will fall in this range and be a goal. If it's above, no goal. All right, shall we use the range equation? Alex, is yours written down? You're supposed to have a sketch of it by now. Can we use the range equation on this one? What are your thoughts? Zach, you've already thought this through. Can we use the range equation? Because the range equation, whoops, these aren't level, are they? I have to move over here. Start at one end and end at the same height. So this could possibly be at the same height. It might end up that it's right in the goal, at the goal line, or just a smidge after it, but we don't know, so we can't use the range equation on this. Is that clear that we can't do that? Because if it ends in the goal, like at the top, like right here is where we're cutting this problem off. If it ends up here, it's definitely not at the same height it started. So unless it's clear, we can't use the range equation. So what would you suggest that we do? We're going to pull out some of our unknowns. So if you would, for some bingo points, give me XO, V, and that V, we'll get to X, but just not yet. V, O, V, A, T, and X. Let's get all the information in the X direction first. Then we'll decide where to proceed. So if you can fill in that information correctly, I'll give you a bingo for that. I hear calculators coming out, so that's a good thing to hear. We're coming up with as many of these 5 parameters as possible in the X direction. Why did I pick X direction? I could have picked Y. It's just sort of a place to start.
So the range equation won't work here.
Pardon? It won't, because it may not. It's possible that it'll zoom in this goal up here, which is a different height than when it started. So range equation has to be at the exact same height at the end as it started. Are you alright with that, Alex?
Yeah.
Are you an Orioles game?
So the range equation, is that like the voting equation or something?
No, it's the range equation is R.
Oh yeah, I remember now.
B sub O squared, what is it, sine of 2 theta over
You
T.
could add it, but
It sort of simplifies our work when we can use it. Otherwise, we have to go through this list twice, pick equations, and bounce from one to the other, which is what we're going to do. All right, let's go around and tell me what you got. Brian, do we know velocity initial in the X direction?
Yep.
What is it? How do we get it?
22 meters.
That's not in the X direction. That's the number one
No, that would
place.
be 0.
That's in the X direction. We have some velocity. Let me show you. Watch, I'll show you.
Velocity in the X direction is yeah.
See, we have some velocity in the X direction. I just drew it in green. And this is velocity in the Y direction. So Brian, back to you again. How could I find the length of this green part, which is the velocity initial in the X direction? It has something to do with the 22, but it's altered somewhat. Do you recall?
22 cosine 45 degrees.
Right. Could you get that number for me, please? All right. This is the number one spot on the testing day where students lose points. They do put 22 in here, but it has to be adjusted by the fact that this is at an angle, and we're only interested in the horizontal part of that. All right. 22 cosine 35. Brian, you have a number on that?
18.
Oh, I'm sorry. 18.
18.02
All right.
or something like that.
All right, so 18, if you got 18 on that, you may cross out a point. I4. So that was I4. All right, velocity, Emily, what do we get for velocity final in the x direction?
The same as velocity initial?
Right. We usually only use one or the other, but they are the same because velocity, and if you take a vector and go across in the x direction, you'll see that the x velocity is always the same. It's constant. So if you were able to indicate that it's the same, you may cross out B2. All right, the acceleration, Zach, over to you. Acceleration in the x direction. Right, there is no acceleration because the velocity stays constant. If you drove here in your car to this morning and never ever changed your velocity, you would have had no acceleration and probably an accident. But we won't talk about that. Right, Alex? B3.
We don't like those.
Yeah.
That suck a little bit.
B3, if you were able to tell me there was no acceleration in the x direction. All right, time in the x direction. Do we have any information on that, Emily? Pardon?
That's what we're trying to find, right? Well, we don't have it.
All right, so this is missing. Missing in action. All right, if you knew that it wasn't known, you can cross out G4 and x in the x direction. Do we know distance in the x direction, Alex?
Distance in the x direction, yes.
And what is it?
Distance in the x direction. Distance 22.
That's the velocity.
Velocity, so,
So you
be
can
32,
tell,
be 32.
right, meters per second. All right, Alex, you squeaked in, I'll give it to you.
Yeah.
So 32. Yeah. I3. All right, so now, do we have enough? Emily, you get to help us. So this is how you start a problem. You just pick a direction and go down all the parameters. Do we have an equation that this suggests?
Yes.
Which equation?
The second one?
Which is the squall?
Yes.
Well, the problem with the squall, and I can't really say that you're wrong but the problem with it, this zeroes out, and these are the same. So it's not that it's wrong, but it leads to a dead end.
Right, okay, so then you go to the y side.
Which one?
The y. And
The y
time.
side, no, but still lead me to an equation that is reasonable.
Third one.
Which one?
Third one.
Yeah, the voters. So x equals v sub o t plus 1/2 at squared. All right, so Emily, when I stick these values in, what comes out? Could you put them in, please, for me?
Yeah, 1 second.
I can
But
just
you
say-
don't have, the one having Q, like, cancels.
Yeah, just do as best as you can. You're not going to be able to complete the problem. So what do we have so far?
32.
32 equals,
18, and then,
and we're doing all this in the x direction, so I'll put in a little x's. All right.
wouldn't the one have 18 squared cancel out?
Right here, right here.
I know, but the 1/2 18
Yeah,
would cancel out, right?
because why does it cancel out?
This is 0.
Right, acceleration is 0, so I won't even
Yeah.
go there.
Yeah, 18 t.
For 18
Yeah.
and t. I'm sorry, I didn't hear that part. All right, So that's sort of it. On this part, we were able not to find what we wanted, but can we not find time at this point?
Yeah.
All right, so go ahead and the question does not ask for time. It asks, will it be a goal, which is a question and why, which really means how high is it? But we're gonna need time, so we went down this path for a reason. All right, so Emily, what is 32 divided by 18?
1.77.
1.7 what?
77.
Does it round up or does it say 1.7?
That's just 1.7 repeating.
1.777?
Yeah.
All right, so we'll round it up.
1.78.
1.7, yeah.
So I'll round it
Or,
up.
yeah.
Okay. 1.8 seconds. All right. If you were able to come up with time like we did, you may cross out N2. All right. So notice the strategy here. I went for time, and that is going to help us now find the question, will it be a goal? This is a question and why, but I'm going to need time, so I started in X. Sometimes you have to start in Y to find time to answer a question in X. So this is the other way, but you'll see the technique is very similar. All right, so let's go down the Y path. All right. If you would, go ahead and write down those parameters in Y and fill them in. You in video land, do the same. Velocity initial in Y, final in Y, acceleration in Y, time in Y, and distance in Y. That's what we're really interested in. How high will this ball be in 1.8 seconds?
You might need to shut it down.
Okay, let's go ahead. We can do that while we're filling that out. We'll be right